Okay, recording now, so I'll get my stuff set up while I talk a little bit. There's nothing in the chat. Let's see. See what's happening there. All right, so you should have gotten your score over the weekend. The scoring for this particular one, again, I gave you the video for the answers. So if you want the answers, I gave that out also on Saturday, I think it was. So there were 11 questions. 11 times 10 is 110. So there were 110 points available, but the highest you can score is 100. Okay, so think of it as there was one extra credit question, but the highest you can get is 100. So some people actually got higher than 100, 101, 102, 105, 107, or something like that. The highest you could have gotten is 100. So it was essentially one extra credit question. Okay. The previous exam, I only gave 9 questions, and I made up a bogus 10th question, which was a free 10 points. So I'm not promising I always do that, but they told us we're going through the pandemic, try to make things quote unquote a little bit easier on the students. So that's my contribution, I guess, to making it a little bit easier for you guys. But again, I don't promise that for the 4th test or the 5th test, but be that as it may. Okay, so if you got over 100, the highest you can get is 100. Sorry about that, but you should be happy about the fact that I'm giving free points away, so to speak. Okay. All right, so we're more than halfway done. I think we only have 7 weeks left. 1, 2, 3, 4, 5, 6, 7. Yeah, only 7 weeks left, and those weeks are not all full weeks. We've got holidays coming up very soon. To me, every time once we reach November, the semester just flies by because we have like there's Veterans Day, Thanksgiving, and then once we reach December, right, we're pretty much done, and the holidays begin and all that kind of stuff, right? So just looking at the schedule, so we're in chapter 4. The next exam is in 3 weeks, Friday, November the 13th, which happens to be the week where we have a holiday also. Okay, so it's another one of those, I call them one-day weekends. So if that's the case, I'm going to try to finish everything, I guess 4.8 by Tuesday the 10th. Okay, so Wednesday's a holiday for Veterans Day. Then let's make Thursday, I'll try to finish everything by Thursday, and then that'll be a Q&A session, and then Friday will be the test. Okay, and then after that, we just have one more test just before our last day, I think. And that cuts through the Thanksgiving holiday also. So, we're finishing up pretty fast. Okay, so looking at this, so we got rid of the biggest chapter. That was the biggest chapter. So then we have chapter 4, which has not 8 sections because we're skipping 4.6. Okay, what are we doing 4.6? I think it's called calculus with computers and calculators, which I'm not requiring you to have a special graphing calculator or computer to draw stuff. So that's that. There is a 4.9, as I said before, I'm holding that up to chapter 5 for some reason. Okay, so the next exam will cover this. All right. All right, so we'll get started with stuff from 4.1. All right, so here we go. We'll jump right to the questions. Okay. I did talk last time about maximum and minimum, and we will sort of reinforce those ideas today. All right, so on our homework assignment, we're supposed to start off with 3, I think it was, 3 to 43, and so on. Okay. So let's see what that's about. And yeah, let me go ahead and do this again if you don't have the book and don't plan on getting it. Page 283, it looks like. So there are some problems. Oops. That. Some more. Off the video later. Next page. We only had to go up to what, 61, so you don't need that side there. So page 284, more problems. You up to 47 or so. And 61 is the last one. So anything after that. Okay. All right, so number 3. So they give you some x values, a, b, c, d, r, and s. Okay. I can understand why they don't want to say e. E means, 2.718 and so on. They don't want to say f or g or h because that's often used for functions. So a, b, c, d, r, s. Okay, so do you have a maximum or minimum, absolute or local, or neither? Okay, so I don't feel like writing it. I'll just say it, and you can just write it on your own. And by the way, so our abbreviations, maximum, you can always write max, M-A-X. Minimum, you can write min, M-I-N. I will do that. Okay. Local, L-O-C, or again, I'd say relative, R-E-L. And absolute, A-B-S, for abbreviation. This is all being recorded also. Okay, so point A looks like a relative maximum, right? It's relatively the highest, but it's not an absolute maximum. Okay, so relative maximum at A. You can put R-E-L-M-A-X. Okay, B looks like a relative minimum, right? So B, put down R-E-L-M-I-N. C looks like a relative maximum, so R-E-L-M-A-X. D doesn't look like anything, neither maximum nor minimum. Okay, R is the absolute minimum, right? It's absolutely the lowest. So absolute minimum, ABS, min. And like we said last time, if it's an absolute minimum, it's also a relative minimum. So you can put ABS minimum and REL min. And likewise for S looks like the absolute maximum. So if it's the absolute maximum, it's also a local maximum. You can put local, L-O-C, or R-E-L. Okay, so if you're the highest in the world, you're the highest in your neighborhood also, so to speak. Okay, so that's all. Okay, 5, take the absolute and local max and mins of the function. Okay, so let's see what we have. So 0, 1. Oh no, sorry, 0, 2. So put down 0, 2 is a local min, right? So L-O-C-M-I-N, or you can say relative. I'll use both expressions. I'll say relative, you can put R-E-L, or local, L-O-C. Okay, 1, 3, we're going to call that a relative minimum. That counts, because if I go a little bit to the left or a little bit to the right, you only look higher. Okay, in this case, much higher. Okay, so 1, 3, local min, and no max over here. Okay, so this point is a local min. What's that? 1, 2, 2, 2, 2, local min. And how about this point here? That looks like an absolute max and therefore automatically a local max. That's 1, 2, 3, 4. 4, 1, 2, 3, 4, 5. Okay, so 4, 5. 4, 5 is an absolute max and also a relative max. All these answers should be in the back of the book also. Okay, by the way, it doesn't look like there's an absolute minimum. Okay, there's an open circle here, so I cannot say y equals 1 is a minimum. It doesn't quite reach y equals 1. You can't say 1.1 because you got 1.01. You can't say 1.01 because you got 1.0001 for y values. So there's no absolute minimum, looks like. Okay, we do have a local min right here. So where's here? 1, 2, 3, 4, 5. 5, 1, 2, 3. So 5, 3 is a local min. And that looks like a local max, right? So if I go to any nearby point, I'm only going down. Here, much further down, but that's okay. So local max here is, where's here? 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. So 6, 4, a local max or relative max. And that's about it. Okay. All right, now sketch the graph that has certain properties. Okay, I know some of you put something in the chat. I can't read it right now. so I can't get to it later. Sorry. Okay, f is continuous from 1 to 5 and has the given properties. Okay, so let me write down number 7. Continuous at 1 and 5. Absolute max at 5. And that means that x equals 5. Absolute min at 2, that means x equals 2. Local max at 3. Local min at 2 and 4. Okay. Minima, say what's minima? Minima is the plural of minimum. Okay, so it's 1 minimum, 2 minima, 1 maximum, 2 maxima. So if you see maxima, say what's this maxima stuff? M-A-X-I-M-A, that's plural for maximum. So we're not supposed to say minimums or maximums. It's minima and maxima. That's just the way it is. Okay. So here we go. The function's only continuous from 1 to 5. Okay, so we got nothing else there, I guess. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And they don't really give me any y values, so you can let the y values be just about anything. Absolute max at x equals 5. So I'll just put it somewhere. So how do you know what the y coordinate is? They don't tell me, so it can be anywhere, just so long as now it's higher than anything else, right? It's absolute maximum at 5. Absolute minimum at 2. So 2 is absolutely the lowest. So I just got to put it down somewhere. I'll put it on the x-axis. See, how do you know it's on the x-axis? You don't. You could put it here. You could put it way down here. It just has to be lower than this. But for the rest of the graph, this is absolutely the highest. This is absolutely the lowest. Okay, now I have a local max at 3. So it's higher, but it can't be higher than this, right? So maybe I'll just go like that. Okay, local max. Local minimum at 2 and also 4. So at x equals 4, it's a local minimum, so I should go down somewhat, but not as low as this. And the local minimum at 2, well, that makes sense. We already have an absolute minimum at 2. So we have an absolute minimum at 2. You also have a local minimum. And it's defined at x equals 1, so I need some graph here. But since this is an absolute min, it has to be a little bit higher. Okay, so it looks like a good graph might be something like this. Does that make sense? That qualifies everything. Absolutely the highest point at 5, that means x equals 5. Absolutely the lowest at x equals 2. Okay, local max, local min. This was an absolute min, so it's automatically a local min. And then since this is an absolute min at x equals 1, it goes higher, but not as high as this. Okay, so that's the graph there. All right, so that's 7. I'll let you try 9 on your own. 11. 11. Sketch the graph of a function that has a local maximum at 2 and differentiable at 2. Sketch the graph of a function that has a local max at 2 and is continuous but not differentiable at 2. Okay, so 11a. So max at 2, differentiable at 2. Okay, for my abbreviation for differentiable, I'll just put diff. And B, max at 2, not differentiable at 2. Okay, so we said this before. It was something called Fermat's theorem. I showed that to you, I think, last Wednesday, I believe it was. If you have a local max or min, if the derivative exists, then it's equal to 0. Okay. So if it's differentiable, the derivative has to be 0. So something like this. And that's at x equals 2. So I should have drawn x equals 2, but I can draw it now, I guess. Here's 2. Slope is 0. How about max at 2, but it's not differentiable? That means it's like a corner point. Okay, so I'll just make a corner point. So how about something like that? That'll do it, right? So I can't talk about a slope here. It's not differentiable. It's a corner point, but that's still considered a maximum. All right, so that takes care of that. Okay, and then maybe I'll show you some of 13. Sketch a graph function on -1 and 2 that has an absolute maximum, but no absolute minimum. Okay, it didn't say anything about continuous. Okay, so I gave you something called the extreme value theorem. If f is continuous on a closed interval from a to b, then f attains an absolute maximum and an absolute minimum at some numbers between a and b. Okay. So for 13a, it's defined in the closed interval. There's an absolute max, but no, oh, okay, no local maximum. Yeah, they're using terminology which is different than what I've used to. So that's actually not possible. Okay, so that's impossible. So there's an absolute maximum. There's automatically a local maximum. Whoops. Oh, I'm looking at the wrong problem. I was looking at 12, 13. Absolute maximum, but no absolute minimum. Okay, there we go. So that means the function is not continuous. I was looking at the wrong problem. That was the issue. Okay, so it says -1, 2. Absolute max. No absolute min. Okay, so that means it must not be a continuous function. Several ways you could do that. Absolute max, no absolute min. Okay, if there's no absolute min, maybe it just drops down, 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 down. Okay, so I could, for instance, go like so, as an asymptote. There's my absolute max, there's no min. And just make sure it's defined between 0 and 2. So I could just go like that, I guess. That'll do it. So absolute maximum. There's no absolute minimum, and it's defined everywhere between -1 and 2. Okay, so that does it. So that's an example. That should be 13a, I should put. Okay. All right, that takes care of that. Now for the next set of problems. It says, look at the graph. So sketch the graph and find absolute and local max and min, if possible. Okay, so I'll run through a whole bunch of these now. And since I already have it written down, I'll just go right to it. Okay, so problem 15. F of x equals 1/2 of 3x minus 1. X is less than or equal to 3. That's a straight line. You can make it look like y equals mx plus b. X is less than or equal to 3. Okay, well, I plugged in 3. I got 4. Plug in 3. 3 times 3 is 9. 9 minus 1 is 8. Half of 8 is 4. So it looks something like that. So I have an absolute max and a relative max at 3, 4, and there's no minimum, clearly. Right? So sometimes the graph doesn't have a max or a min. That's okay. That's allowed. Okay, 21 says the sine function from -pi/2 to pi/2. Okay, sine of x from negative pi over 2 to pi over 2. Okay. So sine looks like this, right? So absolute max is at pi over 2 comma 1. Absolute min is negative pi over 2 negative 1, and they're automatically relative max. Okay. I use REL here for relative. I use local here, LOC, just so you know that I'm going to use them both for you. Okay. Some people say relative, some people say local, so I'm going to have both of them there. Okay. For absolute, sometimes you hear global, but not that much. So I'm almost never going to write global. I don't have an abbreviation for global. So I'm always going to say absolute. Okay, but global, worldwide, I guess, is sometimes used. But I'll use relative sometimes, local sometimes. Okay, 25, f of x equals 1 minus radical x. So I just drew a quick graph. Okay, you can plug in 0. When you plug in 0, you get 1. If I plug in 1, you get 0. It falls. And you can put infinitely large x values, so it'll just continue to fall. Okay, so the graph looks something like this. So there's an absolute and a relative max at 0, 1, and there's no minimum. Okay. All right, so that's how you do those. Okay, so just draw a quick graph of it, and then you can determine max and min. Okay, now problems about critical numbers. Okay, so last Wednesday I talked about critical numbers. So what are critical numbers? Put on your next cheat sheet. A critical number of a function is a number c in the domain of f. So it's in the domain. The derivative is either 0 or the derivative does not exist. We actually don't do this that much. We have a few examples where the derivative does not exist. But for most of the problems that we'll be doing in this entire chapter, it's going to be we're setting the derivative equal to 0. Get used to that idea of taking the derivative equal to 0. How come? Because that'll give us max and min, right? So like over here, slope is 0, right? Minimum, maximum. So we'll see that theme over and over and over and over in our class for this chapter. Maximum and minimum derivative is equal to 0. Okay. All right, so problem number 33. Find the critical numbers of t to the 4th plus t cubed plus t squared plus 1. So I take the derivative. Derivative is 4t cubed plus 3t squared plus 2t. I set it equal to 0. And undefined, but you can see this thing is never undefined. It's always well defined. Okay, I can factor out a t. 4t squared plus 3t plus 2 equals 0. Okay, so that means either this is 0 or this is 0. So t equals 0. That's a critical number. Okay, how do you set this equal to 0? Well, I did the quadratic formula. Okay, so negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, but if you look at b squared, 9 minus 4 times a, which is 4, times 2, which is c. Okay, this is going to be a negative number, right? 9 minus something which is bigger than 9. This will be a negative. We're not doing any imaginary numbers in our class. It's all real. So that can't happen. So I only have one critical number. That's t equals 0. Okay. Okay. What that's going to lead to later on is we might have a maximum, we might have a minimum at t equals 0. Okay. I'll show you one more like that. I was going to show you 39. F of x equals x to the 4/5 times x minus 4 squared. Okay, that one's a little bit tougher. So it looks like I have to do the product rule, and they give us a pretty bad exponent there, x to the 4/5. So how do I tackle that now? Okay, f of x equals x to the 4/5 x minus 4 squared. So to find the derivative, I need the product rule, right? This is my first function. This is my second function. All right, so f prime of x first times the derivative of the second. So what's the derivative of the second function? 2 times x minus 4. and then by the chain root times the derivative of the inside, but the derivative of the inside is just 1, so don't worry about it. Plus second function, just copy it, times the derivative of the first. So what's the derivative of x to the 4/5? 4/5 x to the negative 1/5. Okay, this is pretty messy. Okay, to clean it up, let's see, I put the 2 in front, x to the 4/5 times x minus 4 plus. All right, so 4 times x minus 4 squared divided by 5. I bring that downstairs as x to the 1/5. Okay. All right, to clean this up, I want to get rid of the fraction, but before I do that, notice that x equals 0 is automatically a critical number. It's defined. I am allowed to plug in 0 here, right? 0 here and 0 here is okay, but 0 is not defined here. So x equals 0 is a critical number, because critical numbers are where the derivative is either 0 or undefined, but it's in the domain. X equals 0 is in the domain. Okay, so looking back again at the definition, for critical number, page 280. Okay. Critical number of a function, it's in the domain, but the derivative is 0 or does not exist. Okay, I've already taken care of does not exist. Okay, x equals 0. Now I've taken care of setting this equal to 0. It's messy, but you can make it much nicer if I multiply both sides by 5x to the 1/5. I don't like that fraction. Okay, so multiply all of this by 5x to the 1/5. Multiply this by 5x to the 1/5 in red. That's easy. 0 times that is 0. So the right-hand side is still 0. Okay, so notice when you take 5x to the 1/5 times this fraction, well, the 5x to the 1/5 is gone. I still have 4 times x minus 4 squared. Okay, now look over here. 5 times 2 is 10. And what's x to the 1/5 times x to the 4/5? Well, x to the 5/5 or x to the 1. So my equation got a lot nicer. Okay, I don't have these weird fractional exponents anymore. I still have to solve that, but it got better. Okay, in fact, I can factor out a common factor. Okay, I don't want to FOIL that out. How about I factor out the x minus 4? Okay, x minus 4 comes out. I have 10x times plus 4 times, there's still another x minus 4. By the way, you might say, can you factor out the 2? Yeah, it doesn't really help that much. The main thing is to factor out the x minus 4. So 10x plus 4 times x minus 4. Okay, this comes out to be 10x plus 4x is 14x minus 16. All right, so these are easy. So overall, my critical numbers are 0. Okay, what number makes this 0? 4. What number makes this 0? 16 over 14, which reduces to 8 over 7. Okay, so that was a lot harder. All right, now for the problems beginning at 47, find the absolute maximum and absolute minimum on a given interval. Okay, they give us a closed interval and we have a continuous function. All of these are continuous. Okay, so how do you know? They're differentiable. What does differentiable mean? You can take a derivative. So if a function is differentiable, it's automatically continuous. Okay, we had something called the extreme value theorem. F is continuous on a closed interval from A to B. Then F attains an absolute max and an absolute min somewhere on the interval. Okay. So now we have a technique for that. Now, I think I alluded to this last Wednesday. Like over here, 417, that looks like a maximum. Absolute maximum. But the derivative isn't 0. Okay? It's just a maximum because the graph stopped. We said there's a closed interval, only go from blah, blah, blah to blah, blah, blah. Okay. In fact, if I didn't make the restriction to be stopped at 4, right? The way the graph is going, it looks like it would keep going up, in which case this will no longer be a maximum. Okay. So in other words, maximum and minimum might occur at an endpoint. Okay. Same thing over here. It doesn't look like the minimum here, but it might be a minimum if we just cut off the graph. Okay, so that leads us to something called the closed interval method. Okay, I think I just said it very quickly last time, but now you can put this, and if you want to put this whole thing on your next cheat sheet, you may. It's on page 281. To find the absolute max and min, notice I hardly ever say maximum and minimum. I say max and min. You know, what is it? 3 syllables as opposed to 1 syllable, right? Okay. To find the absolute max and min on a continuous function on a closed interval. Okay, so find the values of f at the critical numbers. What are critical numbers? Derivative is 0 or undefined. And find the values at the endpoints. You have to plug in the 2 endpoints. So now you got a list. The largest of those will be the absolute max. The smallest will be the absolute min. Okay, so that's an algorithm technique that you need for the closed interval method. Okay, so you can copy this whole thing if you wish. It's on page 281. If you can't write it right now, it's on the recording. You can get the recording later. All right, so for all the problems from where to where, 47 through 61, pretty much the rest of them, right? And that's what I have in mind here. So these are all closed intervals. Closed intervals. So for sure, absolutely sure, you have to check the 2 endpoints. So for 47, which I'm about to show you, you must plug in 0 and 5. For 49, you must plug in -2 and 3. For 53, you must plug in 0.2 and 4, and so on. Then what you also do is take the derivative, set it equal to 0, and also undefined. They don't give us that many that are undefined. It's few and far between. Okay. So you find the y coordinates, and now you have a list of ordered pairs. Just look at all the y values. The highest y value is your absolute max. The lowest y value is the absolute min. Okay, so I'll show you some of those. We've got 15 minutes left. We're good. Okay, so of course my main object is to show you some of each section, right? So I'll show you how to do some of these, show you how to do some of these, show you how to do a couple of these, show you how to do a couple of those critical numbers at the bottom there, 29, 31, and show you at least some of these, right? Okay. All right, so the first time one I was going to show you was 47, the very first one. 12 plus 4x minus x squared between 0 and 5. Now, in general, you don't have to graph these. It's not required. I might graph it just to show you something, but you don't have to graph it. Okay. But on a side note, you should know what the graph of this looks like, right? What is the graph of 12 plus 4x minus x squared? It is a parabola, which happens to open which way? Down, right? So it's a parabola opening down. And we're between 0 and 5. Okay. So here we go. 12 plus 4x minus x squared between 0 and 5. Okay, so I take the derivative, set it equal to 0. So what's f prime of x? The derivative of 12 is 0. Derivative of 4x is 4. Derivative of negative x squared is minus 2x. Set it equal to 0. That's easy. X equals 2. Okay. And you plug in the endpoints. So I have 3 numbers to plug in. 0, 5, and 2. You always plug in the 2 endpoints for these problems. So that would be, again, 47 through 61. You always plug in the 2 endpoints. And you plug in wherever the derivative was equal to 0, so 2. Okay, so I plug in 0. 12 plus 0 minus 0, 12. Plug in 2, right? 12 plus 4 times 2 is 8, minus 2 squared is 4. So 12 plus 8 minus 4, 16. Is that right? And then I plug in 5, the other endpoint. Okay, so plug in 5. 12 plus 4 times 5 is 20. Minus 5 squared is 25. 12 plus 20 minus 25 is 7. Okay, so I have 0, 12, 2, 16, 5, 7. So I just look at my list. So the absolute minimum must be that one, the smallest y value. Absolute maximum must be that one. So there it is, absolute max at 216, absolute min at 57. Just look at your list, the highest y value, maximum, lowest y value, minimum. Okay, so that's the basic idea. Okay, I'll show you just one more of those, and maybe I'll stop after that because I know some of you had something to put in the chat, but I can't see it now. 53. F of x equals x plus 1 over x between 0.2 and 4. So I'm definitely going to plug in 0.2. I'm definitely going to plug in 4. Okay. Okay. So f of x equals x plus 1 over x from 0.2 to 4. Now, before I differentiate, I want to write this as x plus x to the negative 1. Again, if you ever have a constant in the numerator or denominator, I don't want to do the quotient rule. I highly advise you not to do it either. You don't have to. Okay, when it's like this, thinking of it as x to the negative 1, that's way better. Then I don't have to do the quotient rule. Okay, so f prime of x, the derivative is 1 minus x to the negative 2, which is 1 minus 1 over x squared. Okay, is this ever undefined? Yes, it's undefined at 0, but you can see 0 is not in our domain, so I don't worry about it. Multiply both sides by x squared to make it look better. So x squared times that, x squared minus 1 equals 0. Factors in the x plus 1, x minus 1 equals 0. So x equals plus or minus 1, but they told us only to go from 0.2 to 4. X equals 1 is inside that, but x equals negative 1 is not inside that. So the only critical number that I have to worry about is x equals 1. All right, so once again, there are only 3 numbers to plug in. 0.2, 4, just because of the endpoints, and 1 because it's a critical point. Okay, so looking back at this, okay, find the function values at the critical numbers, find the function values at the endpoints. By the way, it doesn't matter which one you do first. You can do 2 before 1 or 1 before 2. Okay, then whichever is the largest y value, absolute max. Whichever is the smallest y value, absolute min. All right, so I'm going to plug in 0.2, 1, and 4. Okay, plug in 0.2, 0.2 plus 1 divided by 0.2, punch it out, comes out to be 5.2. But then 1 divided by 0.2 is 5, 5.2. Okay, you plug in 1, that's easy. 1 plus 1 over 1, 2. 4 is also pretty easy. 4 plus 1/4, 4 1/4. All right, so look at the y values. 5.2, 2, 4 1/4. Which is the lowest? 2. Which is the highest? 5.2. So there we go. Absolute max at 0.2, 5.2. Absolute minimum at 1, 2. And that's pretty much about it for that one. All right, so I think I've shown you everything I need to show you from 4.1. I've shown you some of each type, so you will get started with the rest of that. So on paper, I was supposed to do 4.1 and maybe some of 4.1 tomorrow, but I'm actually done with 4.1. I've shown you enough of that so you can get started with that. So it looks like I can start 4.2 tomorrow. So that should be fine. Okay, so I'm done with that. Let me stop the share and check your questions on the chat. Yeah, okay. Yeah, just about my noise. Yeah, I'm noticing that in my videos that I show you later, I hear it too. It's or blah, 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 something like that. And I have no way around it, sorry. But I think you can still hear it. I listened to myself, I could hear it, but it's not as static like you said. Okay, so that's pretty much about it for that. Okay, all right, so no, you're not weird or hearing anything strange, or you're fine. Okay, so I've got that. I'm done, folks. So anybody have any questions about anything? Otherwise, we can stop. And we're done. So you can either unmute yourselves or put something in the chat. Okay. Your question about 29. All right. Anybody else want something? Okay. Maybe that's all the time I have. Okay. 29 was asked for. Sure, why not? Find the critical numbers. F of x is equal to 4 plus 1/3 x minus 1/2 x squared. And that's about it. And any other questions in the chat? That's the only one, and that's probably the only time I have. Okay, so I'll do this one problem, and then maybe we'll just stop. Again, I don't think any of you have a question about the exam. I think I've given all of you your exam scores, and I told you how I scored it, and you have the video on the solution, so you can always do that. That way, I don't have to take up class time for it. But let me see if I can share the screen again. Sorry, there's no way to do this fast. Okay, so problem 29, find the critical numbers. So take the derivative. That should be 1/3 minus x. Is that right? Derivative of 4 is 0. Derivative of that is 1/3. Derivative of that is x. Set it equal to 0. And I would also set it equal to undefined. Well, this is never undefined. And that's easy. X is equal to 1/3, right? Move the x over. X equals 1/3. So that's the only critical number. Okay, well, I guess it was faster than I thought. Okay. So that's it. And of course, as you know, if I ever get too fast, I realize since I have the video, I realize I can afford to go a little bit fast. I'm not intentionally trying to lose you guys or anything, but because of the fact that you can always check the video, I can quote unquote afford to go a little bit faster. Okay, anybody else, please? Okay, why don't we call it a day? All right, so tomorrow I'll start section 2. You can get started with the section 1 homework, and we'll see you tomorrow. Okay, bye everybody. Have a good day. Okay, bye.